Hello everyone, I welcome you all to the e-videos prepared for Anna University syllabus under the Regulation 2021. Today we are going to see the session on the topic scheduling algorithm. The first scheduling algorithm that we are going to see in this video lecture is first come first serve FCFS scheduling algorithm. And the second unit, process management, in the course CS 3451, Introduction to Operating System. Myself, Dr. C. Rani. Let us see the objective of today's session is to know about the FCFS scheduling algorithms. And the outcome of the session, the students may be able to understand how the FCFS scheduling algorithm works. So the outline of today's video lecture is first come first serve scheduling algorithm definition, and what are the advantages and disadvantages, and let's have a look over the some of the solved problems. So scheduling algorithm, here are some of the list of scheduling algorithms. First come first served FCFS scheduling, shortest job next SJN, or otherwise called as shortest job first SJF scheduling algorithm. Priority scheduling algorithm, shortest remaining time scheduling algorithm, it is SRT. Round robin, that is RR scheduling algorithm, then multi-level queue scheduling algorithm. First, we will see about the FCFS scheduling algorithm, which is the simplest scheduling CPU scheduling algorithm, and which is also a non-preemptive scheduling algorithm. The process that requires the CPU burst is allocated the CPU first. When a new process is arrived, then it is stored in a tail of the ready queue. When the CPU is free, it is allocated to the head of the. So whenever the new process arrives or enters, it will be stored in the tail of the ready queue. Whenever the CPU gets free, the process, it is allocated to the head of the queue. First come first serve scheduling algorithm is a simple algorithm wherein which the jobs or the processes are scheduled based on the arrival time. So the implementation, first come first serve scheduling algorithm is implemented based on the FIFO, first in first out queue data structure. The process or the job which comes first in the ready queue will get the CPU first. It is a non-preemptive scheduling algorithm. Advantage of this FCFS is very simple to understand and easy to implement. The scheduling algorithm. The disadvantages of this FCFS scheduling algorithm is it has a poor in performance, as the waiting time, average waiting time is high. Okay. If we have 5 processes or 3 processes in which one process will be waiting for a long time, which will make a poor performance of the process. Okay, it is a non-preemptive algorithm, hence the starvation may occur. So first come first served algorithm is the simplest algorithm. The disadvantages is that if you're having the two processes, process 1 and process 2, even the process 2 have less CPU burst time. That is, the time taken for the process 2 is very short. It has to wait until the completion of the process 1. So starvation occurs, which makes the poor performance. This is in case of FCFS scheduling algorithm. This is the disadvantages. Let's see the problem 1. Consider that there are 3 processes, P1, P2, and P3, that arrive at the time 0. So it's the arrival time for the process P1 is 0. And the burst time is, CPU burst time is given in milliseconds. For the process P1, it took 24, CPU burst time is 24 milliseconds. Process P2, 3 milliseconds. Process P3, it took 3 milliseconds. If the processes arrive in the order P1, P2, P3 and serve, if you apply or solve using the FCFS order, we'll see what the solution is. So the problem is solved with the help of the Gantt chart. Here you can see 3 processes P1, P2, P3. The arrival time, the waiting time is for the process P1 is 0, and the waiting time for the P2, process P2 is 24 milliseconds, and the waiting time for the process P3 is 27. So the average waiting time is 0 plus 24 plus 27 divided by 3. We get 17 milliseconds. This will be the average waiting time. Suppose if the same problem, if the processes arrive in the order P2, P3, P1, the results are shown in the following Gantt chart. The waiting time for the process P2 is 0, and for the process P3 is 3 milliseconds, and for the process P1 is 6 milliseconds. So 0 plus 3 plus 3 divided by, since there are 3 processes, we need to divide it by 3. So the average waiting time is 3 milliseconds. Whereas in the previous waiting time, it took 17 milliseconds. So if you change the order of the processes, we will be getting the different average waiting time, different results we get. So coming on to the problem 2, the process P1 has a burst time 12, P2 has a burst time 6, and 3 has a burst time 9, and the arrival time is depicted here. So if these 3 are the problem data given, we need to calculate the start time, wait time, finish time, and the turnaround time. Okay, so the waiting time is calculated using the formula. The difference between the start time and the arrival time will be getting the waiting time, and turnaround time is calculated using the formula. The difference between the finish time and the arrival time. Now we can proceed with the problem. What are the data given using the Gantt chart? For the waiting time for the process P1 is 0, and waiting time for the process P2 is 12, and waiting time for the process P3 is, for process P1 is 0, for the process P2 is 11, and for the process P3 is 14. So we need to add all these 3 waiting times to calculate the average waiting time. Is 0 plus 11 plus 14 divided by 3, we get 8.33 milliseconds. Next, we need to calculate the turnaround time. Average turnaround time is, turnaround time we get it from the difference of finish time and the arrival time. So 12 minus 0, 12. 18 minus 1, we get 17 milliseconds. 27 minus 18, 4, we get the 23 milliseconds. Finish time minus arrival time, we will be getting the turnaround time. So the average turnaround time is 12 plus 17 plus 23 divided by, that is 52, divided by 3, we get 17.33. So we need to calculate the average waiting time as well as the average turnaround time. Next, we'll proceed with the problem 3, which are given the CPU burst time for the process P1, P2, P3, P4, P5. And the arrival time is 0 for all the processes. We need to calculate the start time, waiting time, finish time, and the turnaround time. As usual, the waiting time is calculated from the difference of start time and the arrival time. And turnaround time is calculated from the finish time, difference of finish time and the arrival time. The solution is depicted using the Gantt chart. For the process P1, the waiting time is 0. And for the process P2, 10. For the process P3, 39. 42 for milliseconds for process P4. 49 for the process P5. So the average waiting time is 0 plus 10 plus 39 plus 42 plus 49 divided by 5. Since there are 5 processes, we need to divide it by 5. We'll get the 28 milliseconds. And calculating the turnaround time, it is the difference of finish time and the arrival time. So 10 minus 0, 10. 10, 39 minus 0, 39. 42 minus 0, 42. 49 minus 0, 49. 61 minus 0, 61. Since the arrival time given in the problem is 0, we'll get again the finish time value as the turnaround time. If we need to find the average turnaround time, then we need to go for adding all the turnaround times divided by 5. 10 plus 39 plus 42 plus 49 plus 61 will divided by 5 will get 40.2 milliseconds. So here the 3 problems are solved. Whatever the process given with this given data, we need to find the waiting time and the turnaround time. And analyzing the first come first served scheduling algorithm, what are the merits we have? It is better for long processes. It's a simple method to proceed because only minimum overhead on the processor. And the demerits or even very small process needs to wait for its turn to execute to come to utilize the CPU. Short process behind the long process results in lower CPU utilization, and throughput is also not focused or not emphasized. So these are the references used for preparing the slides. Thanks for watching. Thank you.